and then will I just put the A's and the N's subbed into that thing,
Yeah.
and so would that be uh 1 plus? Oh, sorry.
No, I was just doing it.
Yeah. 1 plus half minus 2x.
Two. So n is a half. A half times minus 2x.
Plus um a half times minus 1 over 2 factorial.
Yep.
And um times minus 2 x squared.
Yeah. This thing. Sorry, minus 2x squared. Yeah.
Plus half times half minus 1 times a half minus 2
Yeah.
over 3 factorial.
Mm-hmm.
And then just put that into the calc, and then plus dot 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 and put it into the calculator.
And don't forget the ax cubed at the end here.
And times minus 2x cubed.
That's it. Yeah, so put those into the calculator without the x's.
Okay.
Okay, so do you want to try putting in the last one, and I'll put in the 2.
Yeah. I was going to ask, so that formula can be used for any binomial expansion question that comes up into the paper.
Yep.
Okay.
Well, actually, like it's valid when ax is between 1 and minus 1.
Yeah.
So ax is between minus 1 and 1, and so that's when you would use it. You would just use like if it was just a normal number like the power 4 to power 5, you would just do the normal binomial expansion, the much easier one.
Okay.
Yeah. Okay. So you put in the 3 one, I'll put in the 2 one. Fraction, and I'll do 0.5 as a half.
What did I have to press again, sorry, to get factorial?
Shift x to the minus 1 in the middle.
Okay, choose.
It's got the yellow x with the exclamation. 0.5 minus 1 over 2.
So, when I got minus 5 over 2 x cubed.
Okay. I get minus a half. So minus a half x squared minus 5 over 2, was it?
Yeah.
X cubed, and then we have 1, and this one is, what is this one?
Minus x.
I believe so. So that's it, up to x cubed. What would be part B?
Do I just need to sub in 0.01 into the thing we just found out?
Yep. Go on, sub it in, see what it is.
Zero point 9899475.
0.98. What was it?
99475.
Okay, 475, and then let's just check. Square root of 2 SD. Ooh, are we off about something? Maybe we have a minus sign, or maybe that's just what it is. Let's see. No, that's it. 945. So it's just an approximation.
Okay.
Was there any more to that? No. And no. So believe it or not, that's the first fractional one you did. But you did great because it's the same formula. Any questions there?
No.
Okay. And there was only the kind of. All right. How would we do this one?
So will that just be 2 plus x times 1 plus 5x to the power of -1 or minus a half?
Minus a half. And so just to save some time, let me just go back. I'm going to change this to be 2 plus x over that,
Okay.
which is the same as what you just said, 2 plus x times, in this case, 1 minus 2x to the power of minus a half.
Yeah.
And so how can we find the x squared term?
Just by would it just be by timesing minus 2x to the power of minus a half and then timesing that by x?
Yep. And we already expanded this second bracket.
So would it just be x times minus 2x or
Yeah. What would you get there?
minus 2x squared?
So x times minus 2x gives you minus 2x squared. There is another way that if you fully expand the double brackets, like the brackets, you'll end up with another x squared term. So this is our expansion. If you're multiplying it by 2 plus x, first thing you do is multiply everything by 2.
Yeah.
What would be the x squared term when you do that?
X minus x squared.
Yes. So there's two. You know, when you expand like a long bracket, you often get like, you know, an x cubed, 2x squareds, somewhere in there, 2x's. So this is how you would end up with 2x's, by doing 2 times minus a half x squared. So that would give you an x squared one. And when you're expanding by the second bit, x, you would end up with minus. Hang on, that should be minus 1x, shouldn't it? So you said x times minus 2x. Where did you get the minus 2?
I think it was just from minus 2x times x.
So you were doing this up here. I see. So you use your expansion. So this second bracket is the same as this second bracket down here.
Yep.
Like up to the point of x cubed. And so, yeah, you just write it in this form. So you expand the second bracket. And if you knew from the beginning, you wouldn't need to do x cubed, because we know that would be too big for the x squared term.
Yeah.
Any questions about that?
No.
So we can practice it. I just wanted to. I thought it might be quicker than just doing like a lot of work for this extra thing. Do you remember question B?
No.
The range that it's valid for is ax is between -1 and 1. What is a? The formula only works for this type, 1 plus ax to the n.
So state the range of values of x in Spanish.
So if you were expanding these brackets, what is a?
Would a be like 2 times 5x plus 1 times x?
A is 5.
Okay.
5x, ax. This first bracket is normal. Nothing weird about that. It's this second bracket that is to a power of a minus or to the power of a fraction. That's the one that you have to use this formula for, and it only works in the form of 1 plus ax. In this case, a is 5. They want to solve for x.
So x is greater than minus a fifth and smaller than a fifth.
And do you remember fancy way of writing that?
It was like magnitude of x is smaller than a fifth.
That's it. Great exercise. Throw it in. Any questions here?
No.
Okay, that's gonna come up, and so that kind of answers your question about like when is this valid, when is it not valid. You know,
Yeah.
you have to have a negative and fractional answer on the top. Okay. Hang on. In this expansion, the coefficient of x is 20. I just want to do a more normal exam question before we come to that. So these are the exam questions. 1 plus, find this, x squared term, that's okay. X equals the exact value, that's fine. The percentage error, if we go back, because again, I don't want to have to spend a lot of time redoing. Remember for this one, we said it gave us an answer of 0.9899475, but that actually root 2 is this number. How could you get the percentage error?
Could you do like 0.9899475 divided by root 2 times 100?
I think that's either it or very close. I think it is the difference between these two.
Okay.
So it is root 2 and then minus our answer. Hang on, let's make a fraction first. Minus our answer, 0.9899475. So if I was to do it without the fraction, it would just say like this is how wrong you were.
Yeah.
But then we change it to be like as a percentage just to normalize it. So roughly 30%. We were roughly 30% wrong or something. Okay. Let me just make sure. So percentage error for C is that. Yes. Hang on, I just want to see if I can use their values. Oh, it's just so much. Does this make it easier? Yeah. Hang on. Show that when x is 100, the exact value of the f of x is that. A 0, 1. Are we able to find the percentage error without having to do this whole question? These are the answers for A and B.
Is it 30% or?
So that was for the previous one. For this one, let's see. What were we trying to approximate? The f of... No. Okay, we'll just keep it normal. I'm throwing too much at you. Wow, it's just relentless. Just relentless. Take the range of values for which this is valid. Okay, this is a bit more normal. Okay, but that's probably too easy. Okay, so this one here, how would you begin this one?
So would I make 1 minus 6x the power of a half?
Yes, and then you would go about it as normal.
Yep.
What if there was a part C, find the range of values for which the expansion is valid?
Would I just do literally magnitude of x is smaller than a sixth?
Yeah, so long way would be that. X is in between minus a sixth and a sixth. And that's, they put that there. Magnitude of x is less than a sixth. Decimal approximation. I think you'll be fine for that entire question. I don't think it's going to be in any way difficult. So that the exact value, an approximation. There's, yeah, this one. Hang on. show that when x is 100, the exact value is this. Let's see. So part A, you just expand the brackets. I think you're going to be okay. Part B, you just sub 1 over 100 into your expansion, and you get this.
Yep.
And then part C, part C, substitute into Binomial expansion, and find an approximation of root 97. Was that not? When x is 1 over 100, the exact value. Oh, all right. I'm just going to have to bite the bullet and do a long question. I was just trying to do these like quickly, get through them. All right. They're just enormous. Right. Let's do these one at a time. All right. Let's go for it. How about this one?
So do I need to use the formula here again?
Yes, they want the coefficient of x, so you can do just the x term.
So is that just doing k times -4 times x? Is it just minus? Oh, will it be -4k equals to 20?
4k equals 20.
And so k is -5.
So k is -5. Oops, -5. And part B.
So that would be -4 times -4 minus 1 over 2 factorial times k. Oh no, minus 5x squared.
Well done. Okay, see what you get there. That's my guess.
Yeah, you're right. Yeah, 200. Yeah, it was. Yeah.
Okay, so the coefficient of x squared is 250, and the coefficient of x, so this one was 20, so k was 5. Let's take a look. K is -5, and the coefficient of that one is 250. Okay, and so it's quite common for them to just say what is the coefficient of x squared or what is the coefficient of x cubed, and it's so you don't have to expand and like do an entire expansion. Any questions there?
No.
Okay, so this is exam question. Right, we better do it.
So
Nah. Sorry, I know you must be sick of me, but it's just such a waste of time. Okay, expansion A is done. There's our expansion. Okay, what is B?
is that just subbing in 1 over 100?
Into what?
1 plus 3x over 2 minus 9x squared over 8, etc.
I don't think so. I think it is subbing it into the f of x up here, and then in part C, you'll do what you just said, subbing it into R1.
Yeah, okay.
So try that.
So Yeah, the answer was root 103 over 10.
Okay, so the f of 1 over 100 is root 103 over 10. It's a I'm gonna show that. So it's a show that question. So I would sub it into like square root 1 plus 3, 1 over 100, and then just say it's root 103 over 10. And then question C.
So I just need to sub in 0.01 here.
Into what?
Oh, I need to find the percentage error first.
You can't find this percentage error first. You can only find that last. The error between what and what?
So am I subbing in 0.01 into the 1 plus 3x over 2 thing?
Yes, that's it. Yeah, and you can use 0.01 if that's easier to sub in.
Yeah.
For the working out, I'll just do as the fraction. They gave as a fraction.
Yeah, I got 1.0. I got 1.01488988.
Say it again. Sorry, 1.01.
488.
Okay, and
Oh, there was some more. Shall I say them or no?
yeah, go on. Yeah.
9188. And
Okay.
that's
Percentage error.
so. Yeah.
So root 103 over 10. So root 103. Fraction first. Root 103 over 10. So root 103 over 10 is exactly so that would be 1.014889,157. So we're like slightly off. So
Yeah.
so what is the error? How do we get the error?
Do I just do the 188 minus 157?
Yep.
So. Or actually, do I just need to do 1.01488988 minus root 103 over 10?
Yeah.
Yeah. Okay. So. It gave me a number.
Tiny
So
number?
it gave it in standard form.
That's all right. So they wanted it as a percentage. So we just gave like the absolute amount. How would we convert that into a percentage or as a proportion of this one?
Should I just add percent at the end or something?
So we would have to do. So I just didn't want to overload your calculator. Basically, it's this value is how much out we were. You do that out of root 103 over 10, the exact amount, and then times 100 for 100%.
Okay. So. I got an even smaller number.
Okay, what is it?
It's in standard. It's in standard form again.
Go on.
3.10287.
Okay, times 10 to the...
Oh, there's more.
It's all right. They said 2 sig fig.
Okay, times 10 to the -6.
That's it, times 10 to the -6. Okay, hopefully we did that all right. So it's basically, so it seems kind of silly, right? And I'm sure that there's some good maths reason for it. So if we go back to our simpler example before, we were doing root 2.
Yeah.
Square root of 2, using the magic of calculators, you press SD, square root of 2 to, 10 decimal places or whatever. Old timey times, you'd have to use an expansion. Using our expansion, we can approximate the square root of 2, and then we can say, okay, what was the error between our approximation and the exact amount? And so it's like percentage change over original times by 100.
Yeah.
Let's see, this is our answer. Okay, so 6 zeros and then 3 1. Yeah, so same thing. Any questions there?
No.
Okay, so this is why I was skipping stuff. Hopefully I didn't skip anything. No, okay. So I haven't skipped anything. Let's take a look at this one. Find the value of K. Find the value. So that's very similar to the one we did, and you got it for a shot. I think you're going to be fine there. That's different. That's different. This one. We did it. Yes, so this was the one. Okay. Copy. Okay, so part A is just subbing into a formula. I'm pretty confident you'll be fine. How do we do part B?
So just subbing in 1/100 into the x in 1 minus 3x to the power of 3/2.
Yep.
Yeah. I got this pretty long. 0.9553392.068.
Okay. They wanted exact value. So you subbed 0.01 or 1/100 into this top bracket, was it?
Yeah.
So 1 minus 3. So it's a 2-mark question, and you want to show that that's the exact value. How can you cheat? Legally cheat?
Just say equals to 97 root 97 over 1,000.
Yeah. What is it, the power of a half the same as?
Square root.
Yep. And that's where that square root comes from. So when you're putting square root into your calculator, it's turning it into a decimal there because there's other stuff going on. But if you were to do it the long way, you would end up with this, like square rooting, etc. It's 2-mark question. 1 minus 3. Maybe if I'm wrong, I'm wrong, and we'll have to do it the long way later on. But I believe 97 over 1000. Okay, C.
So So now I just need to sub the 1/100 into the actual like long expanded thing.
Yes, and yeah, that's why this second question is worth 2 marks, because I remember initially for part B you were subbing it into our expansion, but for part B you sub it into the original, and part C you're subbing it into the expansion. All right, sub it in. What do you get? And I'll just write 1/100. Tell me if you get an answer for that.
Yeah, I messed it up at one point, so.
All right. Squared. 16.
Yeah, I got like 0.955 and so on, some other numbers as well.
Okay, like that.
Yeah.
Okay, part C, percentage error.
So root 97 minus that over root 97 times 100.
There's a whole lot more than just root 97. What's the full thing?
All right, root 97 times root 97 over 1,000.
Yeah. And I suppose you could use answer for the previous one.
Yeah.
Oops. So I'm going to try putting this in the calculator. It's going to be fractions of fractions, I think, though, on the top and bottom. 97. So that minus the answer over 97. Gosh. Okay. Tell me if you get an answer for that one. So, do you see what's on my thing?
Yeah.
Were you able to do that?
Yeah, I got, standard form number again.
That one?
Yeah.
Okay. 5 decimal places.
So,
Oh, that didn't work. Uh, 10 to the minus 6 means it starts with 6 zeros.
yeah.
Including the 0.1. So 0. So 1, 2, 3, 4, 5 more. And then 5 decimal places.
So I just had a little problem with my thing because I think I put ands in and I pressed equals again and it gave me some other numbers and now it's just gone a bit weird.
Maybe we shouldn't use answer then. I have it here on the screen. Can you see it?
Yeah, I got it at the back anyway. Yeah.
Oh yeah, you can press up. Yeah.
So, so there's 5 decimal places. So I just need to do 2.017501753.
2017. 5. That's 5 decimal places. The beginning zeros don't count, but the middle zeros do.
Okay.
Difference between 2,000 and 20,000. I would hope on an exam paper that they would accept that times 10 to the minus 6. Like, I think they should accept that, but I just in case did that. So that was not the end of part C. That was just that part. Oh, maybe I cut off the answer for part C. Did I? But 97 root. We subbed in that value. What am I looking at here? Sorry, I cut off the end of the answer. But that's the percentage error anyway. Okay, any questions there?
No.
Okay, so it's weird, but I think you have the idea. Part B, you sub it in to get the exact value. Part C, you sub it into our approximate expansion to get an approximate value. And then you find the percentage change between the two. So difference over original, or like over exact times 100. Okay. I know we now must go back. These questions are just... okay, this was the one. How would we do this? Any idea about this one? I just want to make sure I didn't skip any examples. That was last time. We were okay with this one. Okay, how do we do question A?
So do I first need to put the two fractions here into powers, like?
Yeah.
So would that be 5 times 1 plus 4x to the power of minus 1?
Mm-hmm.
And 3 times 1 minus 2x to the power of minus 1?
Yeah.
Do I need to find the answer of that?
Let's see. Yeah, let's do just the x squared one. And where's my formula? That's gone. So the x squared one, I believe, was n minus 1 ax squared, and that's over 2 factorial.
So that would be so do I need to expand the brackets with 5 times 1 plus 4x, or?
Yeah, if you want, we can do just the x squared term. We can fully expand them if you want.
Yeah, shall I just do with 1 and 4x and minus 1?
Yeah.
So will that be minus 1 times minus 1 times 4x squared over 2 factorial?
Yeah.
I got 16x squared.
Okay. And I expanded it up to that point. So the first one, the expansion is 1 minus 4x plus 16x squared up to the x squared point. How about the second one? And let's just fully expand the second one. It doesn't take too long, actually, up to x squared.
Yeah. So when you say fully expand, is that like minus 3 times 1 times minus 2x?
Say it again, sorry?
So do I need to just put sub the numbers into the formula again?
Yeah. Yeah.
So uh, um, -1 times -1 times -2x squared over 2 factorial.
Yeah.
I got 4x squared.
Okay. And so the expansion of the first one is 1 minus 4x plus 16x squared. Expansion of the second one is 1 plus 2x plus 4x squared. How would you simplify each term for the question?
Do I now need to multiply by 5 and -3?
Yeah, I forgot about that actually. Yeah, first one times 5, second one times -3. What do you get?
So you get 5 minus 20x. 5 minus 20x plus 80 x squared. -3
Yeah.
-6x minus 12x squared.
Yeah. And simplify that. Sorry, someone's at my door. Sorry, someone else got it. Yeah, sorry, go on.
So should I now simplify that more and
Yeah.
do 5 minus 3? So 2 um 2 minus 26x plus 68x squared.
8 x squared. Let's see. 2 minus 26x plus 68x squared. So this one is big picture. It's two different expansions. You do the expansion of the first, you do the expansion of the second, and then you do the first one take away the second one, which is what you did. And I just thought I would mention, you know the way we did the other ones up to the x cubed and this one up to x squared?
Yeah.
You can just keep going forever. So you could do x to the 4, x to the 5, x to the 6. The problem is, like, the difference is the numbers would get really tiny. And so most of the time we just don't bother. So any questions about part A?
No.
Okay, let's try part B.
So do I just need to do? This is where I need to do magnitude of x is smaller than what?
Yep.
So in this case, would it be like? So is A 4 or?
Yep.
So would it be magnitude of x is smaller than a quarter?
And that would be your final answer?
Yes.
So you got lucky, young man. You know the way there was two expansions?
Yeah.
For the first one, the magnitude of x is less than a quarter. What is it for the second one?
It's less than minus a half.
Yes, or magnitude would just be a half, positive half, because magnitude is positive.
Yeah.
I was doing inequalities with Yana. From minus a half to positive a half at GCSE looks like that.
Yep.
And so the second expansion is only valid for these values. The first expansion is only valid from minus a quarter to plus a quarter. And so for which values is x valid for both of them?
So, sorry, I'm a bit confused.
So for the second expansion, x can be between minus a half and a half.
Yep.
For the first expansion, x can be between minus a quarter and a quarter.
Yep.
Inequalities, what number can x be?
X would have to be the smaller, like the smaller one out of the two.
Correct. And that's why you just got lucky by doing the first one, because that was a smaller one. Technically, they could have had this the other way around. Yes. So there was two inequality things, and you just have to pick the smaller of the two.
Yep.
Any questions about that?
No.
Okay. Question C is percentage error. We did that. You just have to practice that now. This one is exactly the same as the one we just did, which is with different numbers. Is this worth doing, or you think it'd be okay?
I think I'll be okay.
For what range of values of x is this expansion valid?
So here would it be that the magnitude of x is greater than a fifth?
Magnitude of s less than a fifth. Yep.
So,
Why
yeah.
not? Why not less than a third?
Because fifth is the smaller of the two values.
Okay, so you didn't get lucky that time. You got smart. Use that answer to do part C.
So do I just sub in? Oh, it's not valid. Right? Let's use expansion to find h. I don't know.
H of x. H is 0.5.
Do I just have to sub it in?
No. 1 mark. Why can't x be 0.5?
Because it's too big. Because it's between a fifth, so it can't be.
Yeah, that's it. 0.5 is greater than a fifth or something like that. Yeah, 0.5 is not in between minus a fifth and plus a fifth. The expansion is only valid for that. The magnitude of 0.5 is not less than a fifth. Yeah, there you go. Any questions?
No.
Oh, we're just starting to wrap ourselves around this thing. Okay, we did this. Did this. How would you start this one?
So so I just need to make the take 1 plus x and make times it by 1 minus 5x. So it's 1 plus x to the minus 1 and make the entire thing to the power of a half.
Would you know how to do that? What I would have done is, like, this is the same as 1 minus 5x. Oh, sorry. Yeah, square root of that over square root of that. 1 plus x.
Yeah.
And so that is the same as 1 minus 5x to the half times by 1 plus x to the minus a half, because it was on the bottom.
Yeah.
Is that easier?
That is easier.
Okay. I'm just not familiar with the other way. Maybe the other way is, perfectly valid. Okay. How would you do this?
So yeah, formula. So do I now need to do 1 plus half times minus 5x plus half times half minus 1 times minus 5x squared over 2 factorial.
Mm-hmm.
And so I'll just put that back out there now.
Okay.
So
Yeah.
uh,
I was doing different stuff.
pardon, sorry.
I was just doing different stuff. You don't need to worry
Yeah.
about.
So yeah, I got minus 5 over 2x there. Then I got minus 25 over 8x squared.
That's fine. And while you were doing that, I did the second expansion. It was a bit easier, even though it was minus a half, because it was 1x, like a was 1. And I got this. How can we... What do we do next?
Times those two together.
Very good, Andrey. Okay. And we only have to go up as far as x squared. So as soon as we start getting x cubed, we can stop. Okay. What do you get?
1 minus a half x plus 3 over 8x squared.
Yep.
Minus 5 over 2x. And then plus 5 over 4x squared.
Mm-hmm.
Times minus 5. No, sorry, minus 5, minus 15 over 16. 15, sorry, minus 15 over 16.
Were you getting 15 over 16?
Minus 5 over 2 times 3 over 8.
That'll give you x cubed.
So is it?
So that's true. We don't need to do x cubed.
All right, okay. So do I now need to do just minus 25 over 8x squared times 1?
Yeah, well done.
And that's it, I think.
Yeah, simplify.
So 1, and then minus 11 over 4x squared. Oh no.
X would be next.
Yeah. So I got minus 3x.
Yeah. Minus a half, minus 5 over 2.
And then I got minus 3 over 2x squared.
Yeah, 3/8 plus 5 over 4 minus 25 over 8. And that's what we were supposed to get. So this is similar to the other one, where you had to do two different things and then do the first one minus the second one. Except this one, you had to do the first one times the second one. And so you could have gotten all the x squared, and in fact x squared times x squared, you would have gotten x to the 4, but you would just cut those out of your answer. And so that's why I just stopped that one. And then you can just sub in x equals 1 over 8 to get an approximation for root 3. Okay, so any questions about that one?
No.
Right. What do you give yourself for those ones?
I think I'd probably give it a 6.
Well done. I hope that the rest of this chapter is going to be much easier. I can just give you a little idea of it. See, this first one is 4 plus x.
Yep.
Our formula specifically says 1 plus ax. And so the way you would do that is 4 plus x to the half. You factorize out the 4. And so it becomes 4 on the outside, 1 plus a quarter x on the inside. But the way you factorize out when it has a power is it's 4 to the half. But then it's exactly the same type of formula, but you're just timesing by the number that's on the outside. Actually, 4 to the half is the same as 2. And so you would do the normal expansion and then times them all by 2 at the end. So there's still more to do, but I think we're through the worst of it, hopefully. How was that for you, Andrey?
Yeah, that was good, thank you.
Well, I'm proud of you. That's tricky stuff. And I didn't used to teach this. I used to teach like easier stuff, but I'm just now really just sticking with the exam questions. So do you want to continue this next time?
Yeah, continue, please.
Yeah, there's only 3 sections in this chapter, so hopefully we'll be okay with it. What was I going to say? What do you want to do after A level? Do you know what you want to do, like in uni or anything like that?
I think I probably want to do something like economics, something like that. I think probably, yeah.
You better do something like that. You better do something numbersy or brainsy to make this worth it. Because you're able to do it. Okay. Any questions in general?
No, it's okay if I drop my email though, because the videos my mum just sends them to me, so it might just be easier if I just drop you my email.
Yeah, Grant, and I'll just email you directly, is it?
Yes, please. Yeah.
Yeah, that's grand.
Yeah.
Anything else?
No, that's it. Yeah.
All right. Well done, Andrey. You did great. I look forward to chatting again next time.
Yeah. Thanks. Bye.
Right, have a good week. Goodbye.